So we decided to implement data classes into the compiler for our final project. We did this by following the implementation that was laid out in class, where we turned data class constructors into tuples and field references into subscripts. We ended up being able to do this successfully for both integer and Boolean types as parameters. The actual structure of the data class type object changed quite a few times throughout us creating this until we figured out what the appropriate structure was. We landed on was one with two dictionaries, one types that maps the parameters to their types, and the order, which maps the field references into their respective subscripts that they'll be once they get turned into tuples. And then we started working on the type checker. I think for both of us, this was probably like the hardest part of implementing this. It was very confusing at first how to store the information coming in from the data class constructors to then be handled in the field references. But I think once we figured out the type checker, it was pretty easy to implement. So here are those changes. This case handles the data class constructors and makes sure they have the right number of parameters and the right types for those parameters. And then the var case was modified to make sure that all the data class types get added into a global list, the data class var types. And then the field ref case was probably the one that gave me the most trouble. Eventually figured out how to make sure that the argument being referenced is of the correct data class type that the reference infers, and then return the type that the reference has for that data class type. And then the class def pass was somewhat similar in structure to the function def case. It goes through and parses the arguments of the class def's body, which contain the parameters and such, and then creates the data class type structure from that with the types and the orders.
So the changes to RCO were very minimal. We needed to add a case for the class defs, but didn't really need to do anything for those before our new pass. And then we just needed to handle the field refs in a similar way to the way that we handled the function calls on the prims. The new case we needed to create, we just called it tupler. Its jobs were to eliminate class def statements from the AST, turn calls to data class constructors into tuples, and then turn field refs into subscripts to those tuples. We followed the same structure of function we've been using all semester, with 3 recursive functions that parse multiple statements, singular statements, and expressions. And then we eliminated class defs by returning none whenever one is seen in tube statement, and making sure never to append none to the AST in tube statements. And then in the assign case, we had to make sure to add each tuple that gets created to tuple var types, so it'll get added to memory. And then finally in tube X, we handled the field ref case by finding the correct index to use from the order dictionary that's in each data class type. Then we return a subscript with that index. And the data class constructor case is super simple. Just return a tuple with the same args.
And here is a example test case just to show that our implementation is working. This one declares a point with the constants 1, 2, and then returns the sum of those, returns the sum of 1 plus 2. And just to show in the type checker here, they are still in the data class constructor form and with field references. And then if we scroll down to our tupler, that puts it in the form of a tuple and subscript. So if we go to our run tests, there are a few in here that are still throwing errors as intended with the certain assertions. But this first test right here, you can see returns the correct result that we would expect of 3 for 1 plus 2.